Okay, so thanks everyone. It's really a great honor to be able to be here to share with you. So I've been really very excited to have this opportunity to engage with you. I know that that is something that is a very high technology, very recent, and it's many telecom providers as well as network vendors, universities, OTIC. If some of you know OTICs, it's under Orion Alliance Test and Integration Forum Group testing centers. So this is where there are a lot of interest in the app. So a brief understanding of what we have been doing. So we have been engaging with the global players across the world on RIC. So be it non-real time or near real time. Okay, so particularly we have been working with the OSC community as well. So open source community on their open source RIC. And also it's been journey to specify the specifications. We co-chair the test and integration forum group in the US. So I think that is where we actually talk about the specification, what we need to put in the specs. Okay, so that's a little bit about us. Then in future, there's opportunity to be on site. We can share with you more about what VRV has for the world. So certainly education market is one that is not distant from us. So we have been working with US universities across US for 5G and 6G, and as well as Europe and Asia. Okay, so and Singapore as well. Okay, so let me start. So the objective of today is to share about the applications that we have actually rolled out and the market that needs these applications. So I'll share with you what are the interests in the market and where we are heading from the network vendors, those in the Europe, in Korea, in the Japan, for example, and some of them in India. So that's where the powerhouse that is driving this introduction to RIC. And there's been a lot of R&D work for the past few years. Okay, I'll cover RIC test in a nutshell, what VRV has in this market, and industry use cases, priorities, and the use cases itself. Then feel free to have Q&A, a short one. I understand the time is I only have 1 hour. Okay, so let's start. So RIC test in a nutshell. So RIC tester basically allows you to provide the complete testing and measurement for validation of Open RAN. So let me just use the pointers. Okay, here. So validation of the Open RAN RIC and XM and RFs. So we have been working with several XM and RFs. If you were to go to the Plugfest that have been happening for the past few years, 2 slots. One is in May, which just finished. All right, so another one is in November. So we have been engaged through RIC Plugfest. So Plugfest is actually a platform whereby different vendors and telcos come together to say that, okay, we want to check the interoperability of different RIC use cases and make sure that they work. All right, so that's the Plugfest, the purpose of the Plugfest. So, so our solution has been used heavily in the Plugfest, but whether it be the RFs, XFs, working with different vendors and RIC vendors. So I think the key word here is containerized. So the solution today is very much containerized. So you can put it in the bare metal or different hypervisor or virtual machines, as well as into the cloud. Okay, or private cloud or public cloud, it doesn't matter. So it's based on Kubernetes. So some of the terms that I say, if let's say you are not sure, I do not know where to pitch. So whether to be a little bit agreeing that you have already some background, which I reckon so. If let's say certain things are a little bit too complex, so please feel free to let me know, or offline we can actually talk about those things that I mentioned. Okay, so the RIC testers cases are that are interested by the network vendors and the customers are basically 4 components. So one is the compliance. So the first thing first, before we learn how to run, we need to walk, right? So in terms of compliance, whether be the just now there was a mentioning about ANA and real time and non-real time, near real time, and as well as near real time being under the SMO. So we test the O1, A1, and E2 interfaces to make sure that it complies to the standard. All right. So, and also let's say if you increase the number of users or increase numbers of G node Bs, so how the cells, so how does the network perform? So that is the compliance part where many telcos will be interested. So I'll give you an example. We have been working in the PlugFest. I think if you go to the website, we are working with Docomo and also work with Rakuten. And of course, in the Europe, we have been working with Deutsche Telekom and several other players that you can see in the PlugFest. And Nokia is also one of them. Okay, so in terms of XF RF training, this is a part that is very cutting edge, because right now we are leveraging the talk of the town, which is the AI and ML, to really model the different scenarios to make sure that any anomalies were able to address it, correct it, and make adjustment. So the current legacy non-open RAN 5G has a lot of limitations. So the purpose of it is to open RAN RIC is to enable this AI ML training model to be utilized in the RAN. So this is where RIC plays a very, very important role, like the brain, like the brain of the entire RAN, to tell this part what you should do, what you should not do, and how it can improve, and so on and so forth through the different XF or RF. So the third one is the decision making. So in the application of RIC, there is actually a lot of decisions. So you can actually have decisions to say that, okay, let's say there's a contention. One application say you must ramp up your power. Another application say, no, you must ramp down your power. So who made the decision? So this kind of application conflict will happen. So we need to be able to make a prudent decision, or the RIC to say that, okay, under these circumstances, for these subscribers group, which have certain quality of service, I want to make sure that they have this SLA higher PRB allocation, for example, right? And then those that is just usual SLA, they may say, okay, you just have a less power, and let's say if you reconnect, there's no devastating consequences. Okay, last is the benchmarking. So let's say a telco, be it Smart or Globe. So we have also been talking to Smart and Globe. So for example, they will say that, okay, I want to choose between so many apps vendor. So for example, it can be from HCL or some other vendors. So which one, or Capgemini, which one will be better? So how do I compare? All of them say the same thing. So when you validate that in the network or in the lab, you're able to compare what they actually mentioned in their data sheet or explanation is able to be validated and stress test, for example. So that's the 4 value that typically the service provider will want to know. And of course, in terms of network vendor, they will make sure that item 1 is the foundation, right? But when it comes to service provider, the XF is the key, because that's where the intelligence comes in. All right, and then you need to make the RIC smarter, and also make sure that you know which app vendor to choose. Okay, so that is a high-level summary. So I hope that gives you an idea of what is the market's interest. And on the part on the value, so from as I mentioned just now, we have been working in a lot of PlugFest. So, and also we have a range of licenses which we will not cover here, but it is enough to say that the latest use cases that's in the market, VIV has engaged with them. And based on our different traffic model, like mobility model, we actually based on our flagship solutions UE emulator called DM500. So globally, it has been used by many telcos, and in fact, we also have it in the Philippines. All right, so the mobility model software is leveraging from there, for example. So I'll cover use cases such as energy savings or efficiency, traffic steering, and network slice, and geolocation, and several others. Okay, so the key building block of the solution for RIC testing, when we say RIC testing, what comes to your mind? What comes to your mind? The key word here is that when we test the RIC is the system that we want to validate the performance. So we need to emulate the DU and the CU, which I'll show you later with the diagram. And then we actually have different KPI or platform that allows the testing to be done. So one of them, as I mentioned, the interfaces, which is tied to this item 1 here, all the global procedures and load testing. We test the interoperability and conformance. And the second, which is the value, like when we talk to the different telcos in the Japan, let's say, for example, SoftBank, Docomo, Rakuten, KDDI, NCC Fujitsu. The key here they want to know is that how can we mimic the real network? For example, how can we mimic the whole of Manila metropolitan? Right? So this RAN scenario allows you to get the, for example, how smart deploy in the certain location in Manila. All right. Then how we actually position the different base stations and the antenna height or the base station height and the azimuth, the tilt of the antenna, and different parameters. You can actually model them in this RAN scenario generator. So in future, what we are doing is that, so let's say Smart or Globe has topology. So we can actually upload that network topology into the solutions. That means all the base stations topology can be loaded, and then you can say, okay, right now I want to test how to optimize this. I don't want to have too many redundancy, or I don't want to have keep transmitting high power, or I don't want to have unnecessary slices. I want to have better slices for the military or the healthcare. So all these can then be achieved. All right. So the superpower, I'll use the word the advantages of this all is the Epic application validation engine. That is where they make decisions. So the apps that was spoken just now, whether it be the RAP or XApp, is actually being validated as in these 2 points here, point 2 and point 4, to make sure that the intelligence is coherent. They work together and they don't conflict with each other. And also the service provider, Smart Globe, is able, for example, is able to choose between which one is the better choice when they made the decision for purchase. Okay, so that is the summary of the testing of the RIC, and I will discuss more in the further details in the coming slide. So any questions so far? You can type in the Q&A. I think there's a Q&A chat. I don't know whether you have any questions, but please send the questions and you can pause me anytime. Okay. Okay, the next one is next slide. I have to move to the next slide. Okay. So this is the details of what I mentioned, the pyramid. So the takeaway that you can leave after you after I leave and after you leave this session from VRV is that remember the pyramid. All right, just remember the pyramid. The pyramid comprises 3 components. So the need of the market whether be it the network vendors, or be it the apps vendors, or be it the telcos, covers here. Summary. Okay, so they will want to make sure that all these apps are validated. So just now I highlighted a few. And beamforming, massive MIMO, traffic steering, anomaly, load prediction, network slice, and so on and so forth. All right, and then the different topology I mentioned just now, the different 3GPP and also ORAN Alliance defined UE models, anomaly, the reporting, and so that when the RAN reports into the RIC, say, oh, okay, this is what I'm experiencing. This UE is not having the SLA or is having the performance that's not according to SLA. Hey, we need to do something about it. Or we're consuming too much energy unnecessarily because it's at night. The users are very, very few. How come your base station power is still ramping so high? All these intelligence or the reporting will be fed back to the RIC, and RIC together with the apps will say, okay, now I understand that this in near real time, we need to shut down this area, or we need to shut down that area, or we need to allocate more PRB to this, and we need to move some of the UEs from here to there. So these are all the intelligence similar to the 4G SON self-organizing network, but it's much more intelligence. Okay. So just now I mentioned about the mobility models, about you and I as we walk from point A to point B, and or a car moving over the expressway, and the different RF model and topology. So that's a part whereby the service provider is very, very interested, because this is their playground, right? Their playground in the different islands, for example, in Philippines. This is their playground. They need to model the playground. So this is the different specifications according to ORAN Alliance. So there is RC model, NR, and KPM. So based on this, you make sure that we have to make sure that all these are being validated, because these are the skeleton. Just treat it as a skeleton of the entire architecture. Okay, these are the skeleton in terms of human. I try to link to human. These are the bones, that make up the structure, and these are the meat, right? These are the meats that makes out the muscle and everything. And then this is all the understanding the brain, the brain behind it, right? So you can see that with this, a person can function normally. Any questions? Let me check. Okay. So what feature geolocation details use case is for customer experience purposes? So yeah, good questions from Cairo. I will share with you later. So that is the point I'm going to share. So let me move to the next slide. Okay, the questions, please hold the questions. I'm going to come to geolocation later. All right, so this is the part where I spoke of just now, whereby you have the NR RIC or non-real RIC, so that sits on the SMO. So this is the A1, which I mentioned, the skeleton and the bones, okay? And then this the interfaces. And what we do is that we emulate the RAN, which is in this case the UNI, UNI, and also the G node B, in this case the DU and the CU. All right, so this is layer 1, layer 2, and layer 3 modeling. All right, and then this is the mobility I mentioned just now, and certain RF modeling, which we can talk about later. So you can see that basically there are several key, how to remove this? Okay, there are several key parts that I want to highlight here. So there's a lot of realistic traffic scheduling algorithm. This is a bit technical. All right, so if you can ask a lecturer for those who are undergraduates or master students, So definitely the traffic scheduling, round robin, proportional fairness, QoS aware are all part of the scheduling that we utilize in the field, so that we inbuilt into the system. So these use cases are applying to this traffic scheduling algorithm applies to traffic steering, QoS, QE, and service level agreement or network slice. And then on the MAC PDCP radio link control layer, SDAP, pardon me, it's a little bit technical. So they apply to traffic steering and QoS and QoE. And similarly, there's a slice mapping and slice reconfiguration and the apps. So now come to you and me. So in terms of how we use it, whether it be it browsing or email or voice or certain machine learning or certain massive IoT, UILC, EMT. So these are the rich traffic types that we can actually emulate like you and me. And of course, the error corrections, okay? So this is needed, and the CQI measurements. Of course, we need to cover the 4G as well, right? Because the network comprises 4G and 5G. All right, so this is the first part that I want to talk about. And then for the DU-CU, on this part, the DU and CU simulation, L1, L2, and L3 modeling. All right, the covers here. This is a high-level summary, but suffice to say that it will involve deep dive in terms of understanding the details. So the advanced RF model, just I mentioned about the network, right? So people like smart will say that, okay, I want to know, I have my individual antenna tilt azimuth, the power, the gain, the pattern, right? Different kind of antenna pattern. And what the commercial antenna I've already deployed and going to deploy in 5G. So the RF environment based on 3GPP, UMA model, rural, indoor, and outdoor, and compliance model. All these are basically what the local telcos will be actually having, right? Deployed for 4G or deployed for 5G. And then L3, we talk about the RIC, the cell reselection, the handover, which I'll cover later when traffic steering said, oh, okay, there's the network connection is very, very poor. Oh, I must really make sure that the intelligence of the network to hand over to the next cell immediately. So it's more advanced compared to 4G, which I will talk about later. And then the capacity, latency, right? So we talk about MAC or edge today. So we need to make sure that those use cases that in the hospital are accounted for in the URLC. And then scalable. For example, we talk about massive IoT. All right, so I think the low power IoT is coming, as you know, for release 17 under 3GPP. So there's new applications is coming up to allow RIC to be utilized in a greater measure in the coming days as we move towards more use cases. Okay, so let me move on. Okay, what is the target and vision of the RAN scenario generator? So this is a part whereby we actually design the real world RAN, mimicking the real world RAN. So people like you and me and the cars and the vehicles, all right, and even the drones, all right, so we mimic them in 3 dimensions. So we are allowing ourselves or the telcos to build the topology of buildings, the base station, the moving cars. And then, so there's a part whereby all the telcos want to emulate, and they want to deploy, as I mentioned in the first slide, deploy the entire, let's say, Manila map into the software, right? So we are able to model it using the different 3GPP modeling. And as a result of that, we use the data for machine learning and training. And once we load the data from telco into the software system and train it using the RIC such that it's smarter and more efficient, at the end of the day, cost savings for the telco. Okay, so I'll come to geolocation soon. Okay, this is the RAN scenario generator as in a high-level summary. I will not go through the detail, but just to suffice to let you know, there's this E2 cell configuration database where we configure the RAN, the UE, the E2 endpoint, and the E2 node association. Cell to E2 node association is here. All right, this is from the RAN configuration, and then you can see that we have the channel modeling based on the 3GPP mobility, that some of the car is moving from left to right or haywire, no certain pattern, people like you and me. And then we have the procedures here, either closed loop or open loop. All right, so and then we shape the traffic. Just now I mentioned to you the L2, L1, L2, and L3 configuration, and also the RLC PDCP layer. So that's how we actually model the entire RAN to allow the running for full closed loop stacks. So this is in a nutshell how VRV actually has designed the RAN scenario generator to mimic the RAN based on the input from the users as well. So you can have the users' behavior and also the RAN behavior and put them in a software and make it smarter intelligence and report to the RIC, and then let the RIC process and then make sure that the RIC talk to the RAN to say that do this, do that, and execute accordingly. So that is entire system that has been designed in terms of RIC validation. Okay. Okay, this is the apps that I'm going to talk about. So we have network slice, as I mentioned, the SLA assurance. So that will include the traffic steering and anomaly detection. And then we have a massive MIMO and energy efficiency, and then the PCI collisions and optimization for autonomous vehicle and traffic steering. So I'll cover the geolocation use cases coming soon. Okay, bear with me for a while. So this is the entire pyramid again. I just want to highlight that where we use AI. You can see that this application end-to-end validation and benchmarking leverage a lot of AI training with the relevant data from the RAN. So once we have the data from the RAN, we are able to train them and provide a very smart intelligence network deployed in the coming days. All right, so this is where we add value to the entire ecosystem. Okay, I want to talk a little bit about this brain, this AI thing. Okay, so because every day today, everyone talk about AI. You see AI in the newspaper, in all the business times, and that's where the money making is. Nvidia is making a lot of money. We know, right? Their share price is very high, and then skyrocketing. And Nvidia is having partnership with so many people to make AI usable to the commercial industry and consumer, different. So there is this whole talk about AI. So in terms of RIC, the application validation engine, which just now I talked about the brain, right, is where the AI comes in. So we are creating this, and this is a state of the art. So just to let you know that nobody in the world has it, and we are integrating it over time with AI. Because AI, as you know, is pretty new, so we're integrating this AI into the RAN intelligence controller. Okay, so we create the infra for data aggregation and retention. There's a database. I think you saw just now. There's a database. We take the data, and also we input the data, what KPI we want, and then we create the analytical dashboard before anything happen, before the RIC make a decision. After the decision is being made, what happened, and what actions has been taken. What scenarios has been compared, because there are different scenarios, right? When you see in Manila itself, there's so different scenarios. When you are in the indoor, you're in the outdoor, you're in the crowded places, not crowded places, so different scenarios. So we make sure that all this intelligence are gathered, and then we run the simulations and compare the different scenarios based on the telcos decision making criteria. And then we use AI to detect the trend. Okay, so like for example, the trend is that over the past few months, our power consumption is unnecessarily going up, or we are actually deploying a lot of unused resources in the network, or there's certain events that come up whereby the network is not able to manage it, or there's a convergence in terms of the improvement. That means we're actually moving towards our target. Or divergence, actually, you know what we actually talk about? We want to deploy energy saving. We are actually not achieving it. You know, the energy consumption is getting higher and higher. So something is wrong, right? So these are all the artificial intelligence training we are actually deploying in the RIC. And of course, I mentioned about different courses. What is the cost? Why is it like that? Why are the QoS based on the high level service level or premium service level agreement is not being achieved? And what is the correlation between these two use cases, like quality of service and massive MIMO? Massive MIMO and quality of service are supposed to work together, but they are not. What's happening, right? So, and benchmarking. So, you know, by right, these vendors' apps and that vendors' apps, they should work together. But how come I'm not achieving what I'm supposed to achieve? Right? So all this insight we are using AI to provide intelligence. And of course, as I mentioned just now, that control KPI is where the service provider wants it to a certain consumer requirements or the enterprise requirements or government requirements, right? So we provide the analytics for the service provider. Of course, at the upstream, we provide them for the network vendors, right? And then, as I mentioned just now, the conflict avoidance, how to avoid conflicts. So the brain, the people like you and me, you and me, our brain will say that, okay, my daughter wants to go out to shopping, and my son wants to go out to play games. So at the same time, it's a conflict. Then your brain will say that, okay, what should I do? You know, so I should make a decision, right? So whether should I listen to my daughter or should I listen to my son? So so these are all the AI intelligence that's being built in to the RIC. All right. So, and then the scenarios, what kind of scenarios is coming up? So, so this is the prediction that we are actually exploring that will happen in the coming days based on the training. So we predict, okay, in the next 1 year, if you want to save this, you know, I was talking to my son, who's actually, just a side note, he's actually doing an internship in Singapore. He actually studied in Oxford, just came back for 3 months summer break, and he's actually in a company that is dealing with carbon tax, right? So he's very in thing right now with energy efficiency. So carbon tax is very important. So he will sell to people like Olam is using it, and some government organization, food and beverage industry using it. And of course, at the end of the day, we need to predict the next 1 year. All right. So is let's say a smart CEO or group CEO will say, okay, next 1 year, I want to save energy in the RAN, because RAN contribute a big part, right? Because power by 20%. So based on this prediction, I need to predict into the future, next 1 year, next 3 years. How can I achieve that? So if they deploy ORAN, then they will say that, okay, if let's say deploy ORAN in this vicinity, I want to see the ROI in terms of energy saving, and yet the community there, whether the enterprise community or the consumer community, is still happy with smart, for example. So this is a prediction that we incorporated into AI and then incorporate into RIC, and to actually provide that kind of intelligence to the executives. Okay. All right. So a little bit more on the architecture. Just now I talked about the KPIs. So from the user, people like the telcos will plumb in the KPI that they want. All right. So this is talking to the RAN, as we know, this is a RAN, and then we will provide the RIC control to the model over here. So you can see that the other model, mobility model that we talk about, this is what we emulate, the RAN. This is what the complementary RAN we need to be emulated. All right. So, okay, beg your pardon, this is actually connected to the RIC, RAN intelligence controller, the SMO and the RIC. Then we make sure that the RIC will tell them, okay, this is what I want you to do. And then from the RAN, I'll tell the RIC that, oh, this is what happened. Is it diverging from the KPI? Is it converging to the KPI that we mentioned just now? All right, and then we have comparison, and then we observe the KPI, and then this is where we do the run analytics and do the reporting. So this reporting will be generated to make sure that constant understanding of what is the reporting that the telco service provider need to make a decision. Okay, this is a very high level, but we can actually talk more in the detail next time. Okay, industry use cases. So I just want to highlight this, that this is the survey we've done. All right, so basically Massive MIMO is very hot because Massive MIMO and energy saving talk about, you know, saving the world, reducing power. So it is very, very hot, very, very hot, very, very hot, very, very hot. Everywhere you go in the US, in Europe especially, or okay, Asia is upcoming. But definitely in the Europe and the US and even Japan, talking about how to save the world. So Massive MIMO and energy saving is a top interest. And of course, terrific steering is a must. It's like a bread and butter. All right. So, and then QoS is a foundation of it. We must also have QoS because network slicing has been implemented in legacy 5G. As we move to O-RAN, the QoS is a concern, right? Must always be there. And that's where I talk about RAN slicing as well. So you can see the interest is very high for these use cases. Energy saving, this will be old data. If you have it today, this will be, I think, double of this based on what happened the past 1 year. Okay, so these are the very, very hot use cases that the market wants or the telco wants. Okay, all right, so you can see that the priority score is here. I will talk about these use cases: quality of service, traffic steering, RAN, Massive MIMO, beamforming, energy efficiency, and a little bit about this beam management and also grid management. And that's it. Because of time, I cannot talk too many. So, but we can share next time. Let's see if there's any question related to this. Okay, I will answer this. Cairo will answer you later. Okay, I'll talk about geolocation later. Is it like traditional RF planning that needs digital maps? Traditional RF planning tools. Oh, okay. The RIC simulation, actually, in terms of RF models, you can say that the planning tools is a downstream activity. All the planning tools we have, whether it be, I mean, you heard from some tools are TAME, is NEMO. So all these things are downstream activity where you deploy already and then everything is in place, you spend the money, you make sure that everything is supposed to be at the right place, you know, optimized, and then you collect the data and then you feedback, right? So in terms of the RIC test simulation, basically the RF model, it can actually get the data in the past from all these data points, but also more importantly, is able to get the user behavior data. Of course, RF model is talking about RF part, right? So besides the data from the test tool that they deployed or they have tested in the deployment in the field, they also allows the RF modeling based on the standards, all right, and also some RF modeling that actually is prediction that you may not have tested in the field. So one is you have tested in the field, which you can use drive test tool. One is you have not tested in the field, and the other one is based on the specifications. All right, so these are all the sources of the simulations that we actually deploy. And of course, adding to that, the AI intelligence is being imprinted into the RF model to make sure that that modeling is smart and accounts for different scenarios based on the user behavior and the requirements of the energy, requirements of the savings of the optimization of the service provider, depend on the service provider's needs. Okay, so there are many sources, but one of them is the RF planning tool in the field. Okay. So let's move to the next page. Okay, now I talk about geolocation. So okay, geolocation, you can see that under this SMO for NRT, non-real time, we actually deployed for many, it's a foundation. If you see this slide, I think I have this slide. Okay, geolocation here, you can see that where it plays, right? Almost all the use cases are covering geolocation. And this is geo-optimization, all right? So geolocation, I must say, is a foundation of all the use cases in the marketplace. So it's a basic must-have features to allow all the use cases to be deployed. Okay, does it make sense? I hope it does. So having said that, whether it be the load balancing, energy saving, traffic steering, coverage optimization, or massive MIMO, grid or beams optimization, traffic prediction, all require the geolocation. You can see that what it provides is high accuracy of geolocation, geospatial performance stats, location density and trajectory stats, and user plane stats, digital twin, and census management. And of course, you can see that is needed to model to the support of near real-time RIC for low latency geolocation. Of course, when we talk about low latency geolocation, which BRV also have, is very, very precise. So low latency will need that precise geolocation. And then we actually model the characteristic of the normal behavior. I think it answers some of the use cases and how it's being used in terms of the use case. And then it models characteristics of anomalies and mitigations. So when there's anomalies that happen, how do you mitigate? Let's say if there's a flood, there's a typhoon that's happening. It's not every day, right? So there's a typhoon that's coming. So there's an anomaly. How do you make sure that the connectivity is still secure under certain conditions that is anomalies? And of course, the parameters optimization is being used. So I think if you know about complementary of RIC in the core is NWDAF. For those of you who knows the network architecture, this is the brain power of the core, and this is the brain power of the RAN. So they work together, and it's also needed for UE mobility behavior and normal UE behavior that I mentioned just now. And then come to near real time. Okay, so inter-frequency handover optimization, intra and inter, and then multi-user MIMO pairing. And same for non-real time and talking to the E2 node to the RIC, sorry, to the RAN, yeah, to the RAN, based on the measurements going to the RIC and measurement configuration coming down from the RIC. That means the decision making and also the users trace and management stats. So all these things they're talking to the non-real time RIC, all these things require the geolocation. Okay, so you can see over here. So in terms of use case, you can see that these are some of the examples that is requiring the geolocation. So geolocation is very, very important in all use cases in summary. All right, and how are they being used is listed in the blue box, as you can see over here. Okay, I hope that gives you some idea and answer your question on geolocations. And in this case, it shows to you geolocation enhance the accuracy of the, you can see that in beam management, okay, I put this way, for load prediction, accept and RF is needed, for beam prediction is needed, and also and beam traffic steering management. So the geolocation apps provide the geolocation orientation and rich info. So that is where geolocation is foundation of all the applications because of the use cases. So of course, these are the data that you have from the REST scenario generator or the field, the RSRP, reference signal, receive power, and reference signal RQ, and the cross correlation matrix and CQI and scheduling info. All right, so these are all the tools from the RF planning that you mentioned about, okay, that under different dynamic scenario. So the key that legacy 5G is not able to respond dynamically to the changing deployment, for example, massive MIMO. Okay, so all these needs really higher intelligence or people like you guys, right? university professors, master students to make the decision. So I can say maybe legacy 5G is not able to match up. They are just maybe a diploma holder kind of understanding. But if you go up to the master's level or PhD level, then you can understand. Then you can leverage geolocation apps even better. Okay, I put it in a simple way. So 5G have a lot of diplomas understanding. If I move to ORAN and RIC and high level use case, you need more intelligence. That's why AI come in. That's why ML come in, right? So legacy 5G, you never heard of AI ML, but ORAN, yes, AI ML can apply. That's why all the PhD holder, you guys, master students, you guys are the the future generation that's going to bring this AI into the marketplace. Okay, so in summary, for geolocation, it brings extra power to the use cases. And geo-optimized is flexible and many use cases can be addressed. And then, just some Accelerant, Flex, Ericsson, and there's many others, right? There's many others. We've been working with them and for the past 3 years. Okay. So, okay, energy savings. So I want to talk about energy saving because there is very, very important thing in the marketplace. If you talk to anywhere you go in the world, energy saving is very key. And this is the so we have it in the Mobile World Congress. So who went for Mobile World Congress in February? Okay, I just tell you what Amazon CEO say. Amazon CEO saw this demo. He said that I want this demo in my office, and I want everyone who step into my office to know that this is possible and this is what we want to do in the coming days. Right. So basically, what we're telling the world is that through ORAN, of course, in this case, our RAN scenario generator, which I mentioned to you, that there's the playground, okay, playground for the service provider, and we provide the RAN with the Genobi DUCU, and then in this case, it's SMO, non-real-time O1 interface to the Juniper non-real-time RIC, and this application RFs from IRA, and of course, we leverage the Amazon's SageMaker to actually provide a platform for us to deploy in the cloud. So with this, we're able to have a lot of energy saving, around 22%. And we showcase in the marketplace in Mobile World Congress. And there's a huge interest from the service provider and the global service provider. All right. And also, of course, the app vendor as well as the whole entire ecosystem. So this is what is very, very in great demand today. And just to summarize, in terms of 5G, is a greater room for energy efficiency. So just now I talked about massive MIMO, right? So we're 100 megahertz plus channel. So we can suppress the power consumption. We need to, in fact, because 5G allow you to ramp up the power to very high. So for example, if you're, I think Smart and Globe has deployed 64 by 64 massive MIMO. Yeah, so it consumes 5 times the power of 4x4 for 4G. So you can imagine the power consumption. Of course, the power transmitter can also be very high, right? And this, we haven't talked about the beamforming, right? So we need to make sure that the 5G network power consumption when deploying is being addressed. And I think some of the DX power control algorithm is already there based on 3GPP, but ORAN brings in a new flavor and other flavor. So you can see that this is a 30% traffic workload, and as we move to 4G, 5G, and so on and so forth, it can actually provide a greater traffic load. But of course, traffic load, that means more ROI. Okay, definitely telco is happy. Everybody is happy because consumer get the better performance. You and me are happy. We watch Avatar 2, we are happy. We play a video game, we are happy. For those who have teenagers or some who are doing video games. So so definitely we are happy, but then the network vendor is also happy. But when it comes to energy consumption, it's a sad phase because you are consuming too much energy. All right, so the energy consumption can exponentially increase. So that's where it's always a concern globally. So what does VRV does? So VRV provide three things. One is we measure the power using intelligence based on the RAN networks information. And then we provide power analytics. We correlate the power and the required power. All right. So once we know what's the diff between what the KPI that the telco wants and the measurement, and then we use AI to manage the power. So we execute the recommendation, which I have a demo video to show to you. Okay. So we measure the reports from the RAN. Okay. So it can be the data can come from the telco data, or we also have our data that based on the 3GPP. All right, and then we provide the intelligence comparing, and then once we apply AI, we execute. We tell the network, okay, this base station, you this is power now. This you need to do this, you need to do that. Instruct all the network accordingly. All right, so that's how we do it. So this example of the energy savings. So you can see that this is energy usage kilowatt hour, and this is a total cell power. You can see that this friend here is terrible. I think all the telco will not be happy because you are stress testing the cell. All right, so this terrible. This terrible. So, but it could happen. Let's say if there is, I do not know what's the big event. Let's say there's India cricket in Mumbai. Wow, this will happen in the stadium, right? Let's say Singapore, there is a national day. This kind of situation will happen. But you need to mitigate that. You need to mitigate that because this is going to shorten the lifespan of your base station. All right, and also your energy consumption is unnecessarily high. Okay, so and then this is the cell and the UE's movement, which I will show later. And then this is the receive power from the different UEs, and then over time. Okay. So what we do, we actually follow the standards in the marketplace, not VRV standards, including ITU, to actually calculate the maximum power and maximum energy consumption based on the different base station, whether they use a Huawei or Nokia or Ericsson, or in future maybe the ORAN company. It can be Mavnia, or it can be even Rakuten Altiostar. Altiostar is acquired by Rakuten. You know, so different players, Capgemini, Para Wireless, you know, so either so all these things can be recorded and also can be calculated, right? So that's why I say that the sources of calculation of the RF model, different parameters actually is have different sources and energy consumption standby. So we provide the total energy usage, as I mentioned, total cell power and power usage per cell. So that gives the okay. So I'm going to show you this video. I will go through with you some of the key points. Okay, so this interface, I can see that we are more than 20 cells. These are the 20 circles, different colors, so different bands, different cells. All right. So this is an example of 4G and 5G, different frequency. Okay, for example, in certain parts of the Manila. So this is what I showed to you just now. We set the power. And this is energy parameters that we want to achieve. You can see that for 4G is different settings. 4G is definitely lower than 5G in terms of power. So 5G you can see 5,000 watt. I think it's crazy, right? So, but I mean, we are happy, but you know, when it comes to energy, everybody is not happy. So we need to optimize it, right? So you can see the cell plot as I showed to you. So most cells are okay, but this one cell is having a max power transmission. So we need to correct it because in red right now. So the total cell power is crazily high, 2000 watts. You can see here, this is the red color cell that's having issue. So you can see that the orange circles continue to shrink when you deploy the RIC optimization. You can see that. So we reduce the power by half each time every 1 second. So now it's green, that means it's back to normal. But definitely, of course, you can see that the throughput per slice actually dropped, right? So definitely in this case, we need to mitigate, as I mentioned, to different apps, right? So now the network slice will be kicking in. The apps, okay, energy saving, okay, I hear you. You know, I need to transfer all these users because SLA said that they must have certain quality of service. I move to another cell, for example, right? So this is the main idea behind it, and I hope that you have a flavor of energy saving. But it need to work together with other use cases. Okay. Okay, let's move on. Okay, traffic steering. So this traffic steering is quite common. It has been shown. We work with Nokia and PlugFest. That is 2 years ago. But definitely, traffic steering means that when, let's say, you and me, right? So we actually are in the same different cell, can be different cell or a cell edge, and then we actually encounter certain anomalies or certain situations, whether indoor or outdoor, right? And we need to really recognize that the in near real time, all right, near real time, we need to make a quick decision because, for example, let's say I'm in the hospital and you are actually having a critical communication. Let's say you are in the military, all right. So two of us are having these requirements that's very, very stringent, all right. And then something happened in the environment. We need to make sure that this is addressed. So how AI and how RIC comes into play. Okay. So in terms of traffic steering, there is two areas. One is connected mode. So the RIC will follow the policy guidance from the non-real-time RIC and force some UE or service to hand over to other cells. So it can actually, for example, once when I need that kind of SLA, I can, but the weather condition is bad, all right, the connection is bad. So the RIC will actually tell the network to say, push all the UEs that's not important. For example, maybe some IoT devices or whatever, push them to other neighboring cell. All right. So that kind of intelligence, near real-time intelligence, that happen very, very quickly. Because you're talking about low latency, for example. All right, low latency is a key for UIRC application, for example, and also, for example, for autonomous vehicle, right? Because in a split-second, accident can happen. You cannot afford to have 1 second of 1 second I'm okay, because my car 1 second not able to detect the other vehicle. 1 second is fine. 1 second equals a death, right? So all these decisions must be much critical compared to what we have today. All right, compared to what you watch YouTube, there's no consequences, right? So these are the critical connected mode traffic steering that the RIC will enforce, all right, or improve the quality of service and quality experience of some UE. And idle mode, let's say if you want to make sure the idle mode is still ready for connected mode, you also need to make sure that the radio resource, the PRB allocated to a certain group of people is optimized or is given priority. So you can see the optimization of spectral efficiency without additional investment, because all this optimization today, even in the legacy 5G, there's a lot of wasted resources, right? Of course, the network vendor is happy, right? Because I can sell more to service provider. But of course, the service provider also don't have that kind of depth or looking into such granular detailed improvement, because the network vendor need to be able to support it, right? But the network vendor today with the legacy 5G, it cannot support certain requirements. So that is where when O-RAN comes in, that is where all these critical communications can actually add value to the service provider to still maintain the same total cost of ownership, no increase in price, but then in terms of the new use case, the SLA, and the different kind of 5G scenario, I can still support. So that's the key. And also multiple frequency cell types and mobility pattern. All right, so this is linked to here. Okay, the principle, I think I've shared this enough just now for connected and idle mode, but just to highlight the importance of handover done by the RIC to improve or guarantee the quality of service, and nearer time RIC can block some UEs initial access in the idle mode, and install other UEs to reselect other cells, as I mentioned just now, right? So this is a very important principle. So how we do it, basically, you can see that in the 5G, we talk about 5G QoS in identifier, right? So different slices, maybe you and me, we pay this money, X dollar to the telco, and then maybe another group pay this money to another slice, and then another slice, or maybe there are more use cases, right? These are all quite basic ones. There are more critical comp. And then the system configuration is set up already, and then the cell configuration, whether macro cell, small cell, and other model, these are all the 3GPP standard, as I mentioned to you, that is being modeled over here. And of course, the input from the, as I mentioned, input from the current telco network. Let's say they already have a current deployed RF planning resources data that can be input into the RIC. It is definitely welcome, but basically there are more KPI or more sources of information that you can inject in, right? And then the UE distribution that I mentioned to you, whether it be non-uniform or uniform, and the UE pattern, UE behavior, and all these things in terms of UE can be a group of enterprise customers or consumers, all right? But generally for 5G, it's more for enterprise usage. And enterprise can be for different more critical communication or not so critical communications. So all this will be looked into. And then the whole idea is that there is a cell risk selection priority and risk selection criteria configured by the RIC, the user, or the service provider. So the UE will move to either mode and then connected mode based on the traffic pattern, of course, right? And then when the RIC make the call to say that, okay, based on the policy, we need to execute risk selection priority. We will I'll show you some communication protocol later, RC messaging to the network to say that you need to do what? The GNOB, you need to do what? The DU, the CU, what do you need to do to make sure that this traffic steering is being implemented for high priority UEs, for example. So this is the flow. I just want to give you an example. So here's an example, okay? How this works. So network complex. Summary, network is very complex. You need to make decision millisecond, right? So then you talk to the RIC, some mission critical information as I mentioned just now to maintain the QoE. But the question, how can you tell if the accepts are set up to make the right decision all the time? And then there's a conflict, right? Like for example, you want to have energy savings. You go down to the very happy energy saving mode, but your SLA is being jeopardized. So you need to steer away from the problem, right? So how can you trust the network component? And the simple answer is through testing. So we're able to use the RIC and accept to train and validate the different scenarios. So we'll verify the accept working together, improve user experience, and you encounters an anomaly in the cell, negative data throughput, and how we mitigate that. So we will have the RAN emulation, as I mentioned just now, and we'll continue to gather the KPIs in order to validate this execute this traffic steering. So I will not mention this, as I mentioned before, we emulate the UEs and moving. So all these things, once we emulate it, and then the accept will need to work optimally under this condition, right? So this is summary. So in the accept, it actually spot the degradation. All right, so there's anomaly detected, as I mentioned just now. Anomaly detected. Okay, we start with here. So this is the what we emulate. We create the reduction anomaly for UE, right? So as I mentioned just now, this is what we execute, because this one can happen to you and me or to any enterprise customer. Then once it's spotted, you said, okay, the accept detected something funny, right? So we need to communicate with the quality predictor accept. So the quality predictor, what does it do? It predicts the user experience in the serving and neighboring cells. So it starts to be like a policeman, right? It's a policeman now. So look around, look around, look around. So you can say that, okay, the other cells allow these users to kick out some other users, or these users to actually move to another cell, or move to another neighboring cell, or kick out other users to other neighboring cell. So this prompts traffic steering accept. So the accept traffic steering will kick in. And then the accept will initiate a handover request to the RAN for this UE. You'll say that, oh, the RAN, now you need to execute this because this UE is having a lot of issues. And this UE cannot afford in milliseconds, cannot afford to have any jeopardize or drop, even minor drop, or even 10% drop in the quality of service. So it initiate the transfer, and then the user experience is continually achieved or maintained. Right? So nothing will happen, and then the enterprise customer is happy, or the critical communication customer is happy, especially the enterprise market. All right. So that's how the so the key elements here is the RAN, which we emulate, and then the traffic generator, the KPI, the anomaly creation, and then all these are running in the RIC testing.